Good evening. Today is Thursday, March the 4th. Today in pre-calculus, we looked at the three-dimensional vectors, three-dimensional coordinates, and topics connected with going from two dimension to three dimension. So I'll share my screen here and show you a little bit about what we did in that regard. When you're looking at three dimension, if you remember in two dimension, you have your vertical axis, which is your y-axis, and then you have your horizontal axis here, which would be your x-axis, and you divide your two-dimensional plane up into what we call quadrants, 4 quadrants. Now, when you get into three dimension, then what you do, if I can find my cursor here, the third dimension comes across, if you're drawing it on a flat piece of paper, it comes across as this 45-degree line, which runs right through about like that. It's not quite 45, but anyway, so if you kind of look, see, so this right here would be your x-coordinate or x-axis. This would be your y-axis. And then, of course, up here would be your z-axis. So when you look at a point, like if we look at point A, which is, let's say, 1, 2, and 3, it's really kind of hard to graph this so that you can see it if you're working on a two-dimensional here. But what you're doing, you're coming one unit out on the x-axis here, so you'd make a point here, which would be 1, 0, 0. And then on your y-axis, you would go sideways here like this. So if you look back up here, if you say if this is 1, then 2 is about right there. So you can come out here in a kind of like a parallelogram. So here is this, and so you would have this parallelogram like that, and you'd have this like this. So you can see you've come out and you've come across now, and then your 3 would go straight up to a point somewhere about like this. So if you do this, if you look at it, see, if you just kind of come down here, you can visualize a kind of a rectangular solid. It comes across like this, it comes up from the axis like this, see, and it comes down like this, and it comes across like this, and it comes out like this. So you've got a rectangular solid box here, and you're basically going from the back far corner. If you look at a vector like this, you're going from there out to the front top corner of your picture. So now, so if we change this here to a vector, so I'm going to come out here, I'm going to erase these sidebars here, and I'm going to come back in and put my vector symbol, which is vector A, and then I come in here and put my sideways V's. So, excuse me. So that now I have a vector. If we want to look at the magnitude of this vector, the magnitude of this vector is just the Pythagorean theorem extended. So if you come in here, like, remember the symbol for the magnitude is the absolute value here. So it's equal to, and you can just come in here and you go 1 squared plus 2 squared plus 3 squared. And so that's just the Pythagorean theorem. Remember, the Pythagorean theorem says a squared plus b squared equals c squared. So now you have a squared plus b squared plus c squared equals d squared. So if you come down here and work this out, the magnitude of this vector is that 1 squared is 1, plus 2 squared is 4, plus 3 squared is 9. So that ends up being the square root of 14. Now, so that's the way you find the magnitude. Now, if you have two different points and you're trying to find the difference in the vector, so let's say we come in here and we kind of disregard what we got there, and we look. Let's say we have a point C, which is, let's say, 1, 3, and 5. And we have a point D, which is 2, 5, and 7, say. And then we want to find the vector CD. So vector CD is the vector that goes from C to D. So it equals to, it's just x2 minus x1, so that's 2 minus 1. And it would be y2 minus y1, which is 5 minus 3. And then it would be z2 minus z1, which is 7 minus 5. Okay, and if we completed the algebra here, we would basically get 2 minus 1 is 1, 5 minus 3 is 2, and 7 minus 5 is 2. So what that tells us is, and I didn't do that correctly here. I'm going to undo, I'm going to erase it. I'm going to erase these edges here because I shouldn't put I shouldn't put parentheses there because it's a vector. So the vector, I put these the sideways V's here. So when you see that, you know you're not looking at vector, or you're not looking at a set of coordinates, but you're looking at a set of vector dimensions. So, and then if I come down here once again and do the magnitude of CD in a 3-dimension, remember I put the absolute value on it, and that equals to the square root of 1 squared plus 2 squared plus 2 squared, which ends up being, in this case, ends up being 4 plus 4 plus 1, which is the square root of 9, which is 3. So the vector that goes from 1, 3, 5 to 2, 5, 7 is the vector 1, 2, and 2, and it has a magnitude of 3. Now you can also write this vector. Remember your ij in unit vector components, so it would be I, which is 1, 0, 0, plus 2j, and j would be 0, 1, 0, plus 2k, and 2k would be 0, 0, 1. Now that's a little lead into what we're going to get into in tomorrow's lesson. Now, tomorrow we'll be doing a kind of a working through what we've got here. I'm going to go ahead and stop sharing here. If you need to look at this, you can pause it. But remember, tomorrow the seniors will be out at Dolphin Island, so we'll be doing probably just making sure, doing some review with the juniors that are left in class. Now, the other thing, don't forget, if you look at the syllabus, yesterday in class we did the Chapter 8 mid-chapter quiz. So you need to look at the syllabus on OneNote and find the problems that you are supposed to work and go ahead and get those done and send them to me. As always, if you have questions, send me an email and I'll get back to you. Hope you're doing okay.